Let's look at question 51, N queens. So in that question, the input is N. N means you will give a N times N chessboard. And if you play the chess, you know two queens cannot in the same line, same column, same slash, and same backslash. So when give you N, you can create a N grid and then return all the possible N queen in this grid, in this chessboard. So give example, N is 4. So the result is two possible solution. These two pictures show this two possible queens location. Those questions actually normally we can use backtrack to implement. So in the backtrack, we try put the queens in one location and then try to find the next location and then find the third one until we find all N location. Okay, let us to write this framework for the backtrack. So backtrack, and in the beginning we okay, backtrack N. So the first element is N, and then so find the next location, and then we call this N times 1. Okay, and when he finished, so if N is 0, we log it to return list. So this one, they want you return a string to represent the queen location. Dot, it means empty. Q letter means queen in this location. So by this one, we can use some metrics to calculate. And when we do the output, we convert this matrix to the output string list. So we have the chessboard, right? This one, and then we have a function called to is list string to strings, right? This function. So by this one, we do one line from the chessboard grid, and then we know each location in the line, right? So, and here we can use some string builder to do it. So in the each string builder, in the beginning, we have to set lines to 0 to clean it, and string builder append x is 0. We give the q, otherwise is 1 is q, otherwise we give the daughter. And after this for loop, we build the list string, return the new array list. So in this array list, we add string builder to string. We generate this one and return it. So we already have these two strings. So when it's finished, we should put this one to result. So in this backtrack function, we also need to bring this return value come here. So it's return. So add two strings. So now we have a framework for that one. So for that one, we have the return value, and then this one in the beginning, we have to create return value is new array list, and then we bring it here. Okay, the next step, we need to do the very important way to find the next location. So we can try each location, right? And in the beginning, so this is each line we use the y, and each column we use x to represent. So in the beginning, we need to go to the first line. We know in each line have only one queen. So in that one, for backtrack, we know the next queen in which line, right? So in the beginning, this should go to the line 0. So here we have a new one, and is y. Okay, so what is the backtrack? Is y plus 1. So next line, you only can go into the next line. Then we need to find the x. So how to find the x? So we should find the beginning, looking to end of the whole line 0, and x should less than the length of the grid. So because we already used n in this backtrack, so we set up some global n. So global n will set to n. So let's n x plus plus. So each time we find the x. Okay, here if we find the x is work, we do this trace back, and before and after trace back, we need to do one thing. We need to set the chessboard, right? We have a y and x, and after this one, we have a onset cheeseboard. Okay, so we need a how-to function to do it. So void set cheeseboard y and x. In here, cheeseboard y and x will become the 1, and void on set cheeseboard y x. In this one, we unset it. Okay. Now we need to decide how we can know this x, y can put the queen. So one way is we have this cheeseboard, right? They already have a location for exist queens. So in each line, we can check in the same line have the queen on the same column and the same slash and the same backslash. However, this check will be cost the calculating time, right? You need, if this line is very huge, you have to check it. Okay, can we do some convenience to find if the x and y can put the queen? Yes, so we set some flag. For each line, we have a flag. So we have a Berlin line flag, right? And we have a column flag, and we have a slash flag. We have a backslash flag. So when we do it, we only check is line, is this line is valid, and the columns is valid, and in this slash is valid, and backslash is valid. So if this everything is valid, we will do it, right? Okay, so next one is how we can do that one. So first, in the set cheeseboard, we also need to do the line y, because we can use this one. This line y will become the false. So it's next time you cannot use this line. And the column x is become the false. How about the slash? Same thing, right? Slash will be the false, and backslash will become the false too. So we also need other slash index and the backslash index. We will do the same thing for the onset function. Okay, but in the onset function, everything will become the true. So next time you can still use this location. Same line, same column, same slash, and same backslash. Okay, we have this one. But now we have next question: how to decide the slash index? And so we need a calculator slash index and backslash index. So if you give x and y, we can calculate the slash, right? However, one question is what is the faster way? So faster way is if you can give the x and y, I directly tell you this x or y and it belong to which slash and backslash, right? So how to do it? So we can use other metrics to save this slash and backslash index. Okay, so the first we have to initialize this CB, right? We already have the CB, but we do not create it, so this should be created here. So CB is a new int n and n. We know in the Java you create the int array, they will automatically set the 0 value into it. And the same thing, we create the line is a new Berlin n, right? And do initialize for it. Array list arrays fill function is a line. In the beginning we set out everything is true. Okay, we do the same thing for column and a slash and a backslash. Here's a little different. If this grid is n, the size is n, but the slash and the backslash, the size is not n. So you see 1, 2, 3, 4. But for slash is 1, 2, 3, 4, 5, 6, 7. So the slash size will be the 2n plus 1. Oh, this is the slash size. Okay, this is slash size and the backslash size. Okay. And the next steps, we will build the from x, y convert to the slash index matrix. So we will build the slice map and backslash map. So both one will like this one. And we need to fill this to grid to give you give the x and the y location, which I tell you what is this select index. So that's one will from for y equals 0 and so we see here we from the y going down to build this slide, right? And the y less than n y plus plus. So for x 0 and x less than n x. So we visit each one and then we build this matrix. Y and x is which index slash index. So how to do it? So let us see the slash. So in the beginning, we set up the slash index is s equal to y. So you see from here, we to build this one, right? This is a slash. So the first, when the y equal to 0 and x is equal to 0, the slash index is 0. So this one will be the slash and the plus plus. So let's see. This one is a slash index 0. This one is a slash index 1, 2, 3. And then go to the next line. So slash start from the 1. And then you find we follow this one, right? Okay, this is a slash map. We will do the same thing for the backslash. Backslash is from here, here, to here, to here, to here. So it still is from the y to from y is from 0 to from up to down is from 0 to n, and but x is from the n minus 1 to 0. So the same thing here. X is n minus 1 and x is big 0. Okay, that one is backslash map. So now we are ready. We have slash map and backslash map. So in that steps, we directly from the map to get its index y and x. This one from the backslash map from y to x. Okay, let's to say this one. Okay, and call this one. Okay, finally we need to return the return value. So let's use this example to check. We only check the first one. So when the first one, when they go to this location, right? When they go to this location, is y is 0 and x is 1. So they go to the backtrack this one and they pass this setting. Okay, and then they set. So in the metric they set is this one, and in line they set up. Okay, line 0 is you cannot use line y again, right? Actually, we don't need this one. This is useless. The reason is we already set up here, so all line is unnecessary because each backtrack we only go to the next line, so line is not necessary. Okay, and then we set up this column 1, never one can use it, and then set up the slash. This slash will be the 2, right? Cannot use it, so this you cannot put value in here, and then backslash, this line is not used. Okay, and then we go to the next one, find this location, and this location, and then go to next to build this final result string and put in the final result. Okay, let's try to run the code. Okay, it's this typo. New int. Oh, backslash map. This is a backslash map. Okay. Oh, we already removed the line. We don't need it. This one is 2. What's wrong for that one? This is a fail. Okay, it's this typo. Okay. That's so much typo. Okay, this one we need to give the slash index and the backslash index. For it's not the array, so this should be the single one. In which line have the okay. Slash map y. So slash map they give some for slash map. We already set up this one, so y is go to the because the x, so the only problem is y. But when y come here, in the beginning y is 0, right? In the beginning y is 0. let me see this one. Slice map. So index first outer boundary. Why is y number is becomes a 4? It's impossible. In the beginning, this one is a 0, and going when y plus plus y plus, let's debug this question. Y is backtrack plus 1. Yx in the beginning, y is 0, so they go to the 0, no problem. And backtrack again, so n is okay, let me see, backtrack in the beginning is n minus 1 and y plus 1. So next run, n is 3, y is 1, n is 2, y is 2, n is 1, y is 3, n is 0, y is 4. But when n come here, they already, oh, I know the reason. Here we need to directly return. We are done. Okay, and let us submit it. Yeah, we are done. For that question, what is the time complexity? So each time we only run the from n line and then n row. So because every time we this is the backtrack, but every time we know we go to the next line. So I think the time complexity is big O n square. The space still is a big O n square. Thank you for watching the video.